scalar product or dot product of two vectors. The scalar product or dot product of two vectors is defined as A dot B. A arrow dot B arrow equal AB cos theta. Now, A and B here, they represent the magnitude of the vector A and vector B. And this theta is the angle between the vector A and vector B. So therefore, I can say that the scalar product of two vectors is equals to the magnitude of the vectors times the cosine of the angle theta between the two vectors. Okay. Example of scalar product is work done. Work done, that is W, is equals to the scalar product of force and displacement. Another example of scalar product is power. Power is the scalar product of force and velocity. Okay, and so on. We have so many examples of scalar product. So when you look at these, at this equation, at the right hand side of this equation, we see that this A and B, they are magnitude. Even cos theta also is a magnitude. So therefore, A dot B, which is the scalar product, is a magnitude. Okay, so that is why in this example, when I say work done, I write only W without arrow. When I say power, I write only P without arrow because scalar product always give the scalar. Okay, that means it gives only the scalar quantity. Alright. Next is properties of scalar product. The first property of a scalar product is commutative. That is A dot B equal B dot A. Okay. Second property, scalar product is distributive over addition. That is A dot B plus C is equals to A dot B plus A dot C. Okay. If two vectors A arrow and B arrow are perpendicular to each other, so in that case, when A arrow and B arrow are perpendicular, then the angle theta is 90 degree. So when theta is 90 degree, A dot B, which is AB cos theta, here it means AB cos 90. And you know cos 90 is 0, so therefore 0 into AB will be 0. Property number 4. If the vector A arrow is parallel to B arrow, in that case, theta is 0 degree. So therefore, A dot B is equals to AB cos 0 degree. And we know very well cos 0 is 1, so 1 times AB is equals to AB. Okay. Property number 5. The scalar product of a vector with itself is equals to the square of its magnitude. For example, I take the scalar product of a vector A to itself, then A dot A. When I say A dot A, it means magnitude of A cos 0 degree here. Okay, why cos 0 degree? Because you are taking the scalar product of the same vector. So when this is cos 0 here, so cos 0 is 1, so 1 times A is A square. Okay, so the scalar product of the vector with itself is equals to the square of its magnitude. So using this concept here, now we will look at property number 6, which is the scalar product of a unit vectors. So for unit vectors, we have I cap, j cap, and k cap. These unit vectors, they are mutually perpendicular to each other. So this is I cap, this is j cap, this is k cap. Now the angle between any two unit vector is always 90 degree. So in property number 6, following this property number 5, I can see that I dot I cap dot I cap is equals to magnitude of I cos 0 degree. And you know cos 0 is 1. So, but the magnitude of the unit vector is equals to 1. So the magnitude of I only is equals to 1. So cos 0 is 1. So 1 times 1 will be equals to 1. Okay. Now, the scalar product of a unit vector with the other vectors, with the other unit vectors. Like if you take I cap dot j cap. Now this will be equals to magnitude of I, magnitude of j, cos, what is the angle between I cap and j cap? This is I, this is j, so angle is 90 degree. So cos 90 is 0, so this will be 0. Similarly, I cap dot k cap will be equals to magnitude of I, magnitude of k, cos 90 degree, and again this is equals to 0. Okay, right? So property number 7. We know A dot B is equals to magnitude of A, magnitude of B, cos theta. So only cos theta is equals to A dot B upon AB. Okay, and in the next video we shall see how much is this A dot B in terms of rectangular components, and what is the magnitude of A and what is the magnitude of B. So for that we will see in the next video. So these are all about the properties of a scalar product.